In this problem, we're going to talk about graphing linear inequalities. And this involves being able to graph a linear equation, and then the fact that it's an inequality involves some shading and testing each side. So when we're graphing a linear inequality, the first step that we need to do is to be able to identify and graph the boundary line between the two regions, and then test the regions to find out which side needs to be shaded, which side is going to contain the solutions to this inequality. So we're going to start by graphing the boundary line. Okay, and the boundary line is going to be the inequality turned into an equation. So we have 2x plus 5y equals 10. And one thing that we do have to determine when we're graphing the boundary line is whether it's going to be a solid line or a dashed line. So what that means is the line is going to be solid if the points on that line also are solutions to the inequality. It will be a dashed line if the points on that line are not solutions to the inequality. So we can determine this by looking at the inequality symbol to determine if the points on the line are also part of the solution. In this case, our inequality symbol is only greater than. It's not greater than or equal to, which means the points on the line are not also part of the solution to the problem. So we're going to be graphing this as a dashed line. So now that we've identified that it's going to be a dashed line and we've identified what the boundary line equation is, we need to graph that boundary line. And you can graph it by any of the methods that we've discussed on how to graph a linear equation. Generally speaking, one of the easiest ways to do that is by identifying the x and y intercept points and graphing those 2 points and drawing the line. So that's the method I'm going to use. So our x-intercept is going to be when the y value equals 0, and the y-intercept is when the x value equals 0. So in this first case, to find the x-intercept, I'm going to rewrite the equation using 0 as a value for y. So we're going to have 2x plus 5 times 0 equals 10. Well, 5 times 0 is 0, so that leaves me with 2x equals 10. Divide both sides by 2, and we're left with x equals 5. So that's our x-intercept value. So our x-intercept value is x is equal to 5. So now let's do the same thing for the y-intercept. The place where it intersects the y-axis, the x value is going to be 0. So we're going to substitute in 0 for x. So 2 times 0 plus 5y equals 10. 2 times 0 is 0, so that leaves us with 5y equals 10. Divide both sides by 5 to eliminate this 5, and we're left with y equals 2. So our y-intercept value is y equals 2, the point 0, 2. So now I'm going to go and, again, graph this very roughly on my very rough axes that are not very straight, but they are good enough to suffice for this. So here we have our basic XY coordinate axes. So in order to graph the boundary line, I'm going to first plot the points of the 2 intercepts. And the first point is 5, 0. So we have 1, 2, 3, 4, 5. So x equals 5, y equals 0. And then we have a y-intercept of 0, 2. And x equals 0, y equals 2. That's our y-intercept point here. And now we're going to draw the line through that point. And we've already determined it's going to be a dashed line. So we're going to start up here, and as close as I can get, draw this dashed line. Okay, and there's arrows on the end because, this does continue on forever. So what this boundary line does is it's a boundary between two regions. We have this region up on the top here, and that's above the line, and we have the region below the line. And the solutions to this inequality are going to be all the points on top of the line or all the points underneath the line. So what we need to do is pick a point somewhere to test to see if it makes a true statement, and that would be the area that we shade, or if the point doesn't make it a true statement, then the other side would be the area that we shade. So test a point, and the easiest point to test always is the point 0, 0. So as long as your boundary line does not go through the origin, test the point 0, 0. And if that point makes a true inequality, then you'd shade the side that the origin goes through. If it doesn't make it true, then you shade the opposite side. So now I'm going to go back to my inequality here. 2x plus 5y is less than 10, or sorry, is greater than 10. And I'm going to plug in the point 0, 0 to see if this makes a true statement. So 2 times 0 plus 5 times 0, is that greater than 10? And I'm putting the question there because we don't know. Well, 2 times 0 is 0, 5 times 0 is 0, 0 plus 0 is 0. So is 0 greater than 10? No. So this does not, the point 0, 0 is not part of our solution set because it doesn't make this inequality a true statement. Therefore, all the points on the opposite side must be the ones that are the solutions to this inequality. So we graphed the boundary line. We determined that the boundary line was a dotted line because it didn't include the equal symbol, which means that the points actually on the line do not satisfy the inequality. Then once we've graphed the boundary line, we test a point. 0, 0 is the easiest point if it's not part of the boundary line, and determine which side to shade based on whether that point 0, 0 made it a true statement or not.